Hello, everyone. We'll start with the last topic of sequencing series, that is geometric mean. So earlier we have done arithmetic mean. What was arithmetic mean? That the terms that we put in between the two extreme numbers and the resulting sequence should be an AP. So if I have 2 and 40 and I want to insert three arithmetic mean. So x1, x2, x3 are my three arithmetic means. Then the sequence that I get 2, x1, x2, x3 and 14 would be a AP. Similarly here, geometric mean would be that between the two given numbers, we are going to put certain numbers and the resulting sequence that we get should be a GP. For example, heading geometric mean. Geometric mean. Suppose the question is insert 4 geometric mean between 3 and 96. That means between 3 and 96, we are putting up three numbers and the resulting sequence that we get should be a GP. So using that, find A and R first. So between 3 and 96, we are putting in three numbers, x1, x2, x3, and this resulting sequence is a GP. So now using this information, we need to find A and R. So here, what would be my A? A is 3 and what is 96? Which term? 5. There are three terms in between and I've added two more terms, the first and the last. So in total it becomes 5 terms. No? If you write A, N is also missing. A5 is 96. Oh, X4. So this would be A6. A R power 5, 96. Put the value of A. R power 5 is 32. So 32 can be written as 2 to the power 5. So our R would be 2. Our R would be 2. Now using A and R, find out all the terms. So X1 is which term? A2. It is the second term of the sequence. So it would be AR6. X2 would be AR square 12. X3 will be 12 into 2, 24. X4 would be 8. So if I want to find so many numbers, then we can use this particular method. But if I only want to find one AM or one GM, what was arithmetic mean of A and B? When I say arithmetic mean, I'm talking about only one arithmetic mean. So what was the formula for arithmetic mean of A and B? That was A plus B by 2. So now here, if I have only one geometric mean, no. Geometric mean between A and B. So A, X and B are in GP. If these three numbers are in GP, then the ratio would be same. Ratio of second and first and third and second. So here x square is equal to AB. X would be root AB. So geometric mean between A and B is root A. Yes. So if I want to find question, geometric mean between 4 and 9. Answer under root 4 into 9. So under root 36, it would be 6. Yes?
Yes.
Next. Now, the main variety that we need is when we have both AM and GM together. That's the one of the most common 5-marker questions that we get. So, note. In the same example, what would the AM be between 4 and 9? 4 plus 9 by 2, that is 6.5. And geometric mean is 6. So, which one is more? AM? AM is greater than GM? Yes or no? So, if I give you both the numbers to be 3 and 3, what would be the arithmetic mean? 3 plus 3 by 2, 3. What would be the geometric mean? Under root 3 into 3. Under root 3 square. That is again 3. So in this case, AM and GM will be equal. So if both the numbers are identical, then AM and GM are going to be same. But if the numbers are different, they are distinct, they are unique, both of them are different numbers, then AM and GM are not going to be equal. Rather, AM is always going to be more than GM. Yes? No. Number one. For two numbers, A and B, arithmetic mean is A plus B by 2. Geometric mean is root over AB. For any numbers, any positive numbers, if I haven't said anything, whether the numbers are same or they are equal, so anything can happen. So AM is greater than and equal to G. But for distinct numbers, if I have told you specifically that the numbers are not equal, then AM is greater than GM. They can't even be equal. Clear? Now, there will be certain sums where both AM and GM will be there. You either will be asked to find out the numbers or you will be asked to find the ratio, something or the other. Every single sum which will have both AM and GM, we will use a formula of algebra for any sum देखो, where both AM and GM are there. We use the formula. We will use the formula A plus B whole square minus A minus B whole square equal 4AB. So in general, if I give you any two numbers, if I haven't mentioned anything, then AM and GM can be equal also, AM can be greater than GM also. But if I have specifically said that the numbers are distinct, the numbers are different, then AM will be greater than GM, they can't be equal. And whichever sum has both AM and GM in it, we will use this algebraic formula to make our sum easier. Yes? For example, question. The AM arithmetic mean and geometric mean of two positive numbers of two positive numbers are 10 and 8. See, AM is greater than GM, it's given. Question is, find the numbers. Find the numbers. So since we are talking about two numbers, let the two numbers be A and B. Now, arithmetic mean is 10. That means A plus B by 2 is 10. So from here, A plus B would be 20. Geometric mean is 8. So under root AB is 8. Squaring both sides, AB would be 64. Yes. So we have A plus B, we have AB. So in this formula, I have A plus B, I have AB. Use this formula and find A minus B first. We require it or not, I don't care. See, this same sum can also be done using substitution. From one of the equation, I'll find B and I'll substitute in the other equation. That is true, but this can only be applied in this sum. In the other sums, you need to do another method. You have to think of something else. But this algebraic formula that I mentioned, you can use in every single AMGM for sum. Everywhere, it's universal. So we know A plus B whole square, A minus B whole square is 4AB. So this is 400. So 400 minus 64 into 4 is 256. We get 144. So A minus B would be 12. Any problem till here? So now we have two good equations. A plus B is 20. A minus B is 12. Use them and find A. Normal linear equation. A plus B 20. A minus B 12. Adding them. 2A 32. A would be 16. A plus B is 20. Putting the value of A. So B would be 4. Therefore, the two numbers are 16 and yes, done.
Yes, ma'am.
There are three sums here. Done this one. Question. If arithmetic mean of two numbers A and B is twice the geometric mean, find A by B ratio. Find the ratio of two numbers. Okay. So what is given? Arithmetic mean is twice the geometric mean. This is provided. What is arithmetic mean of A and B? A plus B by 2. And what is geometric mean? Root over AB. So from here we know that A plus B is equal to 4 root AB. Yes. So since it is an AMGM sum, we have already written what was provided, what was given. Use the algebraic formula. Apply. We know A plus B whole square, A minus B whole square equal 4AB. In A plus B, put this value. 4 square 16AB. 4AB comes to this side. A minus B whole square. So 12AB is A minus B whole square. From here, A minus B is under root 12AB. 12 can be written as 4 into 3. 4 can come out of the root and it becomes 2 root 3 root AB. Any doubt till you? So again, I have both A plus B and A minus B. Solve, find A and B. Solve and find A and B. A plus B, 4 root AB. A minus B, 2 root 3 root A. B goes away. 4 plus 2 root 3 root AB. Take 2 common. So A would be 2 plus root 3 AB. Similarly, find B. Find B. Find B. Tell me what is B. Hmm? Answer for B. Subtract the two equations. Subtract the two equations. B would be 2 minus root 3 root AB. Therefore, A by B. 2 plus root 3 root AB. Root AB gets cancelled. 2 plus root 3, 2 minus root 3. That is what we were asked to find the ratio. Any problem? Understood?
Yes,
Now,
ma'am.
a similar question. Can I remove this?
Yes, ma'am.
Question. If sum of two numbers is 6 times their geometric mean, show that the numbers are in the ratio 3 plus 2 root 2, 3 minus 2 root 2. Try. Let's see. Let the two numbers be A and B. Let the two numbers be A and B. So AM, sorry. The sum of the numbers, that is A plus B, is 6 times geometric mean. Geometric mean is root AB. Now we can put this in the formula. A plus B whole square, A minus B whole square, 4AB. So 36 AB, 4AB comes this side. 32 AB equal A minus B whole square. A minus B under root 32 AB. 32 is 16 into 2. So 4 root 2 root A. So now we have A plus B 6 root AB. A minus B 4 root 2 root AB. If I add, I get twice A. 6 plus 4 root 2 root AB. Cancelling 2. 3 plus 2 root 2 root AB. Now, if the same equations I subtract, we get B is equal to 3 minus 2 root 2 root AB. So, ratio A by B, 3 plus 2 root 2, 3 minus 2. Root AB cancels out. Done? Done?
Yes, ma'am.
Okay. Now, question only for a geometric mean. You have done in AM also. Find the value of n if A power n plus 1, B power n plus 1, an plus bn is the geometric mean of A and B. Here, an plus 1 plus bn plus 1, an plus bn is geometric mean. So root AB, cross multiplication, an plus 1 plus bn plus 1, ab to the power half into an plus bn. I can open the bracket and put the powers to both of them. A power half, B power half. Multiplying them. A n plus 1, B n plus 1. A n plus half, B power half. Plus B n plus half, A power half. So the numbers with similar powers. Here A has power n, here also A has power n. Bringing to one side. Minus A n plus half, B half. B n plus half, A half. Minus A n plus half, B half. Taking common, taking a power n plus half common, left with a power half minus b power half. On the other side, taking b n plus half common, left with a half minus b half. These two terms get cancelled. A power n plus half equal b power n plus half. Bringing it to one side, a by b power n plus half equal 1. Now, what should I do with 1? Looking at the left hand side, I can write it as a by b power n plus half equal a by b to the power 0. Same base. So, n plus half 0, n would be minus 1. n would be minus half. क्या हुआ? Is it okay?
Yes, ma'am.
ML Agarwal, exercise 6.6. ML Agarwal, exercise 6.6. Okay, exercise 6.6, 1 ka 1. Between 1 and 256, there are three geometric means. So the resulting sequence is a GP. First term is 1. Fifth term is 256. A r power 4. 1 r power 4. This is 4 power
4
4.
power 4.
R is 4. So x1 second term AR, x2 AR square, x3 AR cube. Yes. Question number 2. The fourth term of a GP is 2. That is AR cube is 2. The product of first 7 terms. First, second, third, up to 7th. A 7 times. R same base multiply power and. So this is an AP. Number of terms by 2, first term plus last term. A power 7, R power 21. Taking power 7 common. So 2 power 7. Yes. Question number 4. Between A and B, we have A1, A2. This is an AP. A is the first term. B is the fourth term. So it is A plus 3D. A1 is the second term, A plus D. A2 is the third term, A plus 2D. Looking at it, we want A1 plus A2. So 2A plus 3D. This can be written as A plus 3D, which is A plus B. So A1 plus A2 is A plus B. What we also want is G1 into G2. Again, A, G1, G2 and B are in GP. A is the first term. G1 is the second term AR. G2 third term AR square. G3, sorry, B is AR cube. Now, G1 into G2 because you need that. This is A into AR cube. A is A. AR cube can be written as B. So, the value A1 plus A2 upon G1 into G2 would be A plus B by A. Yes. After 4, we have 8. G is the geometric mean between A and B. G is equal to root AB. 1 by G plus A. 1 by G plus B. G is root AB. A can be written as root A square. G can be written as root AB. B is root B square. Now taking your root A common, root B plus root A. Taking root B common, root A plus root B. LCM, root A plus root B. Root A into root B. We have root B plus root A. It's cancelled. So it is 1 by root AB, which is 1 by G. Then to B here. Done? Okay, question number 10. See, what we want is A by B plus B by A greater than equal to 2. Let's backtrace. This is A square plus B square by AB greater than equal to 2. So I can write this as A square plus B square by 2 greater than equal to AB. So rather than applying AM and GM on A and B, let us applying AM and GM on A square and B square. So we know that AM is greater than equal to GM. Arithmetic mean of A square and B square would be A square plus B square by 2. And geometric mean is root over A square B square. So it happens. Okay, number 9. Minimum value of 4 power x plus 4 power 1 minus x. So 4 power x is a positive number. 4 power anything is a positive number, right? So if I apply AM and GM here, A plus B by 2 greater than equal to root over AB, 4 power x, 4 power 1 minus x by 2. Same base multiply power root over 4, which is 2. 2 goes to the other end. So the minimum value would be 4. The minimum value would be 4. Done? So that's the end of sequence and series chapter.